everyone, this is Kruti Jaipancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Analog and Digital Communication System. Today you will learn about generation of AM in the MATLAB. Now as you know that what is the amplitude modulation? So we learn about the formula, we learn about to find out the modulation index, VM by VC that we done. We have also calculated the bandwidth for same. We have also seen the sidebands calculations. We have also seen that if the modulation index value, that is the small m is equal to 1, small m equal to less than 1, small m greater than 1. So how you can do it practically in the MATLAB? Again, it is also important. So before studying the various methods of generation of the AM, today we are going to generate the amplitude modulated wave for the various values of the modulation index into the MATLAB. So we are going to start the practical very first. Before starting anything with the MATLAB, we are running the command. It is the CLC. CLC, that is the clear screen. Okay, so this clear screen that will be there, that what it will do by running this, you can see that the clear all, okay, it will do everything clear. Now the close all, whatever the applications, whatever the images, plots are available, it will close everything, clear all. We have also defined the few variables earlier with the MATLAB. So this will clear all the variables value with the MATLAB. So after running this CLC, close all, clear all commands with MATLAB, now if you will scroll the cursor or if you will scroll with the mouse to see the history, then that will be not available with the MATLAB. So you can see over here that I am running this. So you can see that now there is nothing with the workspace. So now we are ready to start our script with the MATLAB. So very first we are going to generate the modulating signal in the MATLAB. So I am defining that. Suppose my small m is equal to 1. So now this is small m, that's nothing but the modulation index that I want. So modulation index value, here you know that by writing this, it is the comment we are writing, so that in future if you are referring the program, then you can have the idea about it. Now the maximum amplitude of the modulating signal, suppose I am assuming that it is my wave having the amplitude, it's a 10 volt. So you can also say that this is the amplitude of modulating signal. So this is my amplitude of the modulating signal. I'm assuming that my frequency of my wave, that is suppose the 2 kilohertz. So it is the, you can say that this is the frequency of modulating signal. Now the time, what is the time? It's a 1 divided by the frequency. So this is the time. Now we want to generate the samples at the particular frequency. So from how much time the wave that can be generated? For that, I am defining that value. That suppose this value will start from the this 0. So I am putting the gap for this, that is suppose my whatever the time divided by the 999. Okay, and I need a wave. Okay, that is suppose this value Tm. So this is the gap that I am creating. Now for the x-axis you can give your own time for generating the samples. So this way it is generated. Now I want to generate my modulating signal. I am writing suppose my phi m is my modulating signal. Modulating signal equation that we already studied in the theory. It is what? It's a modulating signal amplitude Vm. Suppose I am keeping the sine wave. So it is the sine 2 multiplied by pi. Okay, sine 2 pi f, that's a frequency, into t, that is the time. So here you can see that it is what? It is the equation for the modulating signal. So now this is my modulating signal. I want to display it in the figure. So I'll just write the figure number 1. I want to make a one plot in which my all three waveforms should appear. So I am using the command of dividing my plot, that is using the subplot command. I want to divide my plot into the 3 parts. So I'll write the 3. I'm writing that my which particular the row. Okay, so it is my the first figure. Okay, and in the first one column. So this is the 3, 3, 1. I want to plot this value. So it is the plot t, comma, which value I want to plot? I want to plot Vm. I want to also give the title of my figure. So I will write it over here. It is what? It's a modulating signal. So the modulating signal, that's my title. So it is the first procedure about generating the modulating signal. Now we have the run command. By running this, you can see over here, it's my modulating signal having the frequency which I define, and here is the value that I specified over here. It's a 6 multiplied by Tm, so it's about the 0.00 t. So you can see that the modulating signal is there. Now similarly, we can also generate the carrier signal. So now next my task, that is to generate carrier signal. Fine. So now we are going to generate the carrier signal. What is the relation? That the small m is equal to Vm upon Vc. So I can write over here my Vc is equal to Vm upon small m. So which we are defining? I need to define my frequency. We know that the carrier frequency, that's a higher frequency. So suppose I am multiplying some factor with my modulating frequency. So now it's my carrier frequency. So now you can see over here that we have the carrier frequency. So here I am writing it's my it's what? It's my the carrier signal voltage. Here I can also say that it's a carrier frequency, which is the higher frequency. So I am multiplying with by the sum factor. So now I want to find out the time. TC is equal to 1 divided by the FC. Now I will write the equation for the carrier signal. It is the VC multiplied by sine of 2 into pi into FC into T. So now what is this? It's the Y signal, okay, and it's a what? So we can write in the comment also that it's what? It's a carrier signal. Fine. So it's a carrier signal. Now similarly the figure number 1 I'm using, so I'm not rewriting it. Subplot, I want to plot it. Subplot, earlier I said I want to divide my plot in how many parts? 3 parts. So I'm writing the 3 over here. Column is 1, and first figure we have also first figure plotted of modulating signal. So now the second figure that I am plotting over here, and I want to plot it. Okay, so what I will do that I am writing the plot T comma Y C. If you need a grid, okay, and again I am writing the title over here. So it's a title, carrier signal. So the carrier signal. So now we'll just run the command. You can see that this is my carrier signal. If you need a grid in the graph, what I will do, before plotting this, I will just write the grid on. So you can see that by the grid on, the waveform that you can see in that the grid is appear. So this is the carrier signal and the modulating signal. Now I want to plot the modulated wave. So I'm writing to generate modulate AM amplitude mode, AM modulated wave. So I want to generate the AM modulated wave. So I do not need any value. I need to just write the final equation. Y is equal to, we write the equation, it is VC plus 1 plus M multiplied by sine 2 into pi into FM into T. So my modulating signal. Now the modulating signal, this multiply with the carrier signal. So now here we will write it multiply with the sine 2 into pi into FC into T. So it is the equation for the modulated wave. So now we are plotting them 3, 1, 3. So this is the plot, subplot. Now we want to plot it. So where do we plot? T, Y that I want to plot. Then I am providing the title for my figure, that is the AM modulated signal. So I am writing this title over here, and now we'll run the things. We can have the over here some bracket that you need to check. Okay, so here the 1, 2 bracket, here 1, 2, 3, and the one closing bracket that is missing. So it is the 1, 2. It is the 3. So 1, 2, 3. So now we'll run the program. So you can see that here we have the AM modulated signal. So this way you can plot the AM modulated signal waveforms. Now this is the waveform for the small m equal to 1. Now if you want to see the small m is equal to 0.5, that is the less than 1, then by using the small m equal to 0.5, you can see that this is the waveform for the small m is equal to 0.5. Similarly, we can also check it for the m greater than 1. So m greater than 1 waveform, you can see that this is the waveform for the m greater than 1. So this way we can generate the waveform for the various values of the modulation index. So now here the code for the modulation index values, okay, m equal to 1, which I specified, and by using that you can have the modulating signal. For the carrier signal, Vc is equal to Vm upon m, and Fc frequency is higher, so 10 into Fa. Tc time is equal to 1 by Fc. It's Yc is equal to V sine 2 pi Fct. Subplot command, I said 3 min. Plot is divided into the 3 parts. 1 min the one column, okay, and 2 min the second figure. So here you can see that the modulating signal, carrier signal. Similarly, for generating the AM modulated wave, y is equal to this equation which we already studied, okay, the final equation that I am writing. So it's my AM modulated wave. Now AM small m is equal to 0.5, the wave would be like this, and small m is equal to 1.5 over modulation. If the over modulation will occur, what happen? That the information that can be lost. So this way you can perform the practical of the amplitude modulation. So thank you very much everyone.